Okay, let's continue on here. Okay, with 1.10. Okay, more nested quantified statements. Okay, so more requested nested quantified statements. So we want to use logic to express, instead of everyone, we want everyone else. Okay, how would we get everyone else? That means I sent an email to everyone else, but I did not send one to myself. Okay. So let M of XY represent X sent an email to Y. So for all X, for all Y, M of XY means all employees sent emails to all employees including themselves. To prevent them from sending emails to themselves, we can use a conditional operation. Okay, and that operation is when X is not equal to Y, then do M of XY. Otherwise, don't do it. Okay. Okay, so let's just take 4 employees and see how this works out. Okay. So the truth table we desire is as follows. Okay, if we take Agnes, Fred, Sue, and Marge, and we put the same for employees, and we want to know who sent who an email, but we want to not send emails to themselves, then whenever we have Agnes with Agnes, or Fred with Fred, or Sue with Sue, or Marge with Marge, along the diagonal is all going to be false. Okay, when X is not equal to Y, then it's true. However, if X does equal Y, then it's false. Okay. So every place else here is true. otherwise false. Okay, so for all x, for all y, where x does not equal y implies send an email from x to y, represents the table above and the scenario that everyone sent an email to everyone else. Emphasis on the else. Okay, everyone sent an email to everyone else. Okay, example 1. Okay, express the following as quantified statements. Okay, A. Okay, everyone sent an email to someone. Everyone sent an email to someone. What would that look like? So the everyone is the X and the someone is the Y. So what would that look like? Okay, everyone X to someone Y of M of XY. I don't need parentheses. M of XY. Okay. B. What if I said everyone sent an email to someone else? Everyone sent an email to someone else. Now what do? Well, the quantified, the universal and existential quantifiers are the same. It's still everyone X sent an email to someone, but we want to not include when X is equal to Y. We're going to say that only applies when X is not equal to Y, then the mail gets sent. Otherwise, it doesn't. Okay. Let the domain of X represent people attending a meeting. Okay. L of X indicates whether or not X came late. Okay. The statement okay, the statement, someone came late to the meeting, can be represented as what? What? How would I represent that? Someone came late to the meeting. Any ideas?
The existential quantifier and then LX.
Yes, exactly. It's just, there you go. Right? Very good. Thank you. Okay, but okay, the statement only one person came late to the meeting. Okay, only one person came late to the meeting. Can be represented as there exists an X such that L of X, okay, someone came late to the meeting, okay, and okay, for all Y, okay, for all Y, okay, so we're creating another variable, Y, okay, and Y is represented, okay, when X is not equal to Y, okay, when, so we're saying, okay, X is the people at the meeting, right? So what would Y be? Y would also be the people at the meeting. It's just, we're doubling up the domain. Okay. Okay. We're saying for all Y such that X is not equal to Y implies this is true, okay, when not L of Y is true. Okay. Okay. So what does this eliminate? This guy here eliminates, okay, it eliminates more than one person okay, coming to the meeting late. This guy has to be true, X has to be true. But at the same time, okay, at the same time, when X is not equal to Y, then the person can't be late. So who's the only person that can be late?
X.
Exactly. Thank you, Shanu. The only person that can be late is X. Y is not allowed to be late. So this eliminates the possibility of Y being true. Or I should say L of Y. Okay. So any other person, okay, cannot be late. Okay, thus, only one value of X could be late. Otherwise, the statement evaluates to false. Since Y is a different individual in the domain of X. Okay, so let's do an example. Okay, example 2. Okay, let M of X, Y indicate that X is married to Y. A of X is that X is an adult. Okay. Okay. X is married to Y. Okay. And then X is an adult. Okay. 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 And the domain are people at a party. Okay. So we want to express the statement every adult is married to someone at the party. Okay. Every adult is married to someone at the party. Okay. Okay, so universal quantifier, every adult Okay. Okay, so if they are an adult, then what? If adult, then what? Then married. Oh, sorry, married to someone at the party, sorry. Married to someone at the party, okay? If they're an adult, there exists a person at the party to which they are married. That's what this means. Okay, every adult is married to someone at the party. Okay, what we can do is we can move the quantifier outside the parentheses. Okay. We can move the quantifier outside the parentheses since, and the only reason we can do that is because A of X does not depend on Y. If it depended on Y, we couldn't do that. But because A of X is only dependent upon the people at the party, okay, then we can move that existential quantifier outside and say that it applies only to Y. Okay, it only applies to the person that X is married to. And so we say that for all X, there exists Y such that A of X implies that they are married to someone at the party. Okay, every adult, if they're an adult, then they are married to someone at the party. Every adult someone at the party. Okay. For every adult, there exists somebody to which they are married. This someone to whom they are married. For every adult, there exists someone to whom they are married. Okay, that's the same statement. Okay, this shows that for all X, P of X implies Q of XY. Right, and implies okay, there exists a Q of XY is logically equivalent to, for all x, there exists a y such that P of x implies Q of xy. Okay. Okay. So, and I'm assuming that it is true if I were to swap the universal and the existential. However, that is illegal. Why would that produce a statement that is not logically illegal, but for all intents and purposes would be illegal in our society?
They would be married to everyone.
Say it again, Eric?
Wouldn't they be married to like everyone at the party?
Yeah, it would say that there exists an adult to whom which they are married to everyone. So, and we don't talk about, you know, the type of cults that are involved in that practice. So, yeah. Okay. So we will stop there.